Good morning, students. Today, let us see the topic how to find number of integer solutions for a linear equation. The equation is y1 plus y2 and so on. Yr is equals to n, where y1 is greater than or equal to 0, y2 is greater than or equal to 0, and so on. Yr is greater than or equal to 0. So, number of integer solutions for the equation y1 plus y2 and so on. Yr is equals to n, where each of yi is greater than or equal to 0 is given by n plus r minus 1 c r minus 1, where n is the right hand side value and r is number of y's. R denotes number of y's. So number of integer solutions for the equation y1 plus y2 and so on yr is equal to n, where each yi is greater than or equal to 0 is given by n plus r minus 1 c r minus 1, where r is number of y's and n is the right hand side value. Okay, so let us see the example problem. So an equation is given, a linear equation is given, x1 plus x2 plus x3 plus x4 is equal to 20. Okay, so under the condition x1 greater than or equal to 2, x2 greater than or equal to 3, x3 is greater than or equal to 0, x4 is greater than or equal to 5. You need to find the integer solutions for this equation under those conditions. Okay, according to the formula, the number of integer solutions is n plus r minus 1 c r minus 1, where r is a number of y's and n is the right hand side. So, okay, so you need to rewrite x1 greater than equal to 2 as x1 greater than equal to 2 as some y1 greater than equal to 0, and also you need to write x4 greater than equal to 5 as y4 greater than equal to 0. So for this problem, I have taken the assumption x1 minus 2 as y1 and x2 minus 3 as y2 and x3 minus 0 as y3 and x4 minus 5 as y4. Okay, so the conditions are x1 greater than equal to 2, x2 greater than or equal to 3, x3 greater than or equal to 0, x4 greater than or equal to 5. So I want to make those conditions as y1 greater than or equal to 0 and so on, y4 greater than or equal to 0. For that, I have taken the assumptions x1 minus 2 as y1, x2 minus 3 as y2, x3 as y3 and x4 minus 4 as y4. So when x1 minus 2 is y1, then x1 will be y1 plus 2, and x2 minus 3 equal to y2, it implies x2 is y2 plus 3, and so on. x4 is y4 plus 5. Substitute the values of x1, x2, x3, x4 in the linear equation, that is x1 plus x2 plus x3 plus x4 equals to 20. So on simplifying, you get y1 plus y2 plus y3 plus y4 equals to 10, where each of y1, y2, y3, y4 are greater than or equal to 0. Now this equation is in according to our formula y1 plus y2 and so on yr equals to n, and each of yi greater than or equal to 0, then the number of solutions are n plus r minus 1 c r minus 1. So here n is the right hand side, n is 10, r is number of y's are 4. So according to the formula, n equals to 10, r equals to 4. So it is 10 plus 4 minus 1 c 4 minus 1, it is 13c3, and 13c3 is same as 13 factorial by 13 minus 3 factorial into 3 factorial. So on simplifying, we will get 286. So there will be 286 solutions for the equation x1 plus x2 plus x3 plus x4 equals to 20 under the condition x1 greater than equal to 2, x2 greater than equal to 3, x3 greater than equal to 0, x4 greater than or equal to 5. Okay, now let us see another example. So in this example, the linear equation is x1 plus x2 plus x3 plus x4 plus x5, 5 variables, is equals to 20, where each of xi greater than or equal to 2. So you need to find number of integer solutions for this linear equation with the given condition. Okay, so you need to rewrite the given linear equation in terms of y1 plus y2 and so on, yr is equals to n with the conditions each of ya is greater than or equal to 0. For that, let us take the conditions x1 greater than or equal to 2, similarly x2, x3, x4, x5, each of xa is greater than or equal to 2. So let us assume it as x1 minus 2 as y1, x2 minus 2 as y2, x3 minus 2 as y3, x4 minus 2 as y4, x5 minus 2 as y5. Okay, so then x1 value is y1 plus 2, x2 value is y2 plus 2, x3 is y3 plus 2, x4 is y4 plus 2, x5 is y5 plus 2. Now substitute the values of x1, x2, x3, x4, x5 in the given linear equation, that is x1 plus x2 plus x3 plus x4 plus x5 equals to 20. On simplifying, you get y1 plus y2 plus y3 plus y4 plus y5 is equals to 10. So here each of yi are greater than or equal to 0, since x1 greater than or equal to 2, so x1 minus 2 greater than or equal to 0, and x1 minus 2 is same as y1, so y1 greater than or equal to 0. Similarly, x2 greater than or equal to 2, x2 minus 2 greater than or equal to 0, and x2 minus 2 is y2, so y2 is greater than or equal to 0. So we have obtained the linear equation y1 plus y2 plus y3 plus y4 plus y5 equals to 10, where each of yi is greater than or equal to 0. So this is in accordance with our formula. So number of integer solutions for this linear system is n plus r minus 1 c r minus 1, where n is the right hand side value and r is number of y's. So here number of y are 5 and n is the right hand side value, it is 10. So it will be number of integer solutions will be number of, so the number of solutions are n plus r minus 1 c r minus 1, n is 10, r is 5, so it is 10 plus 5 minus 1 c 5 minus 1. So 10 plus 5 15, 15 minus 1 14, it is 14 c4 is the number of integer solutions of the equation x1 plus x2 plus x3 plus x4 plus x5 equals to 20, where each of xa greater than or equal to 2. Now let us see another example problem on integer solutions. So the answer for previous question is 1001. It is 14c4. On simplifying 14c4, you got 1001 using the formula ncr equals to n factorial by n minus r factorial into r factorial, and the answer is 1001. Okay, now let us see the next question. Okay, so there is a linear equation x1 plus x2 plus x3 equals to 20. So you need to find the integer solutions with the conditions x1 value is between 2 and 5, and x2 value is between 4 and 7, and x3 value is between minus 2 and 9. So the question is x1 plus x2 plus x3 equals to x1 plus x2 plus x3 equals to 20, and you need to find the integer solutions for that linear equation. You need to find integer solutions for the linear equation using the condition x1 is between uh, 2 and 5, and x2 is between 4 and 7, and x3 is between uh, minus 2 and 9.